Protecting joints too much is exactly what makes them weaker. Avoidance reduces load, and reduced load removes adaptation stimulus. Joints are living tissues that respond to stress, just like muscles. No stress means no remodeling, and no remodeling means vulnerability. Pain often creates fear, and fear leads to complete unloading. But complete unloading decreases tissue capacity over time. Capacity is the amount of load a joint can safely tolerate. When capacity drops, even normal movements start causing irritation. This creates a cycle of pain, avoidance, and further weakening. The solution is not protection, but controlled progressive loading. Loading signals tissues to strengthen, reorganize, and become more resilient. Tendons increase stiffness, improving force transfer efficiency. Ligaments adapt slower, but still respond to repeated mechanical stress. Cartilage benefits from compression, improving nutrient diffusion. Joint health depends on movement, not immobilization. But loading must match current capacity, not ideal performance levels. Too much load too soon exceeds tolerance and triggers pain. Too little load fails to stimulate meaningful adaptation. So the goal is finding the effective minimum dose of stress, enough to signal adaptation, but not enough to overwhelm tissues. This is where controlled tempo and range become important tools. Slow movement increases time under tension without excessive load. Partial ranges can reduce stress while maintaining joint engagement. Over time, range and load can gradually expand together. Isometrics are especially useful in early joint rehabilitation phases. They load tissues without excessive joint movement or irritation. They also reduce pain through neural modulation mechanisms. Pain reduction allows progression without reinforcing fear patterns. Then dynamic loading reintroduces movement under controlled conditions. This restores coordination between muscles and joint structures. Stability is not just strength, but timing and control. Muscles must activate at the right moment to protect joints. Poor control increases stress on passive joint structures. So training must include both strength and motor control elements. Another mistake is chasing perfect form at all costs. Rigid movement patterns can limit natural joint variability. Healthy joints tolerate slight variation without injury. Overconstraint may actually increase localized stress on tissues. Instead, aim for controlled movement, not robotic precision. Now consider load distribution across the entire kinetic chain. A joint rarely fails in isolation during real movement. Weakness elsewhere often shifts stress onto vulnerable joints. For example, weak hips increase stress on the knees. So joint training must include surrounding muscle groups. This distributes force more evenly and reduces overload risk. Progression should be gradual, but also consistent over time. Inconsistent loading prevents stable adaptation from occurring. Small repeated exposures build stronger tissues than rare intense efforts. Consistency is what converts stimulus into structural resilience. Joints become strong when they are trained, not protected. Pain does not always mean damage, but it signals sensitivity. Sensitive joints require graded exposure, not complete avoidance. The nervous system adapts alongside tissues during progressive loading. Reduced fear improves movement quality and decreases protective tension. Protective tension often increases joint compression unnecessarily. This creates stiffness, not true stability or strength. So relaxation and control must be trained together under load. Breathing patterns also influence joint loading and muscular coordination. Holding breath excessively increases internal pressure and rigidity. Controlled breathing supports efficient force transfer through the body. Next, consider joint-specific adaptation timelines across different tissues. Muscles adapt relatively quickly compared to tendons and ligaments. This mismatch often leads to premature loading increases. Tissues feel strong, but deeper structures remain underprepared. This is where many overuse injuries begin to develop. So progression must respect the slowest adapting tissue involved. Tendons may take weeks to months to significantly strengthen. Ligaments adapt even slower due to limited blood supply. Cartilage relies on movement cycles, not direct blood flow. This explains why consistency matters more than aggressive progression. Now examine load type, not just load magnitude. Joints experience compression, tension, shear, and rotational forces. Balanced exposure builds resilience across different stress directions. Avoiding certain directions creates weak points in joint capacity. For example, only training straight lines limits rotational tolerance. Real movement rarely occurs in perfectly controlled linear patterns. So training should gradually introduce multidirectional stress. This prepares joints for unpredictable real-world demands. Now consider recovery as part of joint training, not separate. Adaptation occurs between sessions, not during loading itself. Insufficient recovery reduces the ability to tolerate future load. But excessive rest removes the stimulus needed for adaptation. Balance between stress and recovery determines long-term resilience. Sleep plays a critical role in tissue repair and regulation. Poor sleep impairs collagen synthesis and recovery signaling. Nutrition also supports joint adaptation through protein and micronutrients. Vitamin C supports collagen formation in connective tissues. Adequate protein provides building blocks for tissue repair. Hydration supports joint lubrication and cellular function. All systems interact, not just isolated training variables. Finally, track response, not just performance metrics. Pain during exercise is not always the key indicator. Delayed response often reveals whether load exceeded tolerance. Stiffness or pain hours later indicates adjustment is needed. This feedback guides progression more accurately than guessing. So training becomes a process of testing and adapting load, not blindly increasing weight or volume each session. This approach builds confidence alongside physical resilience. Confidence reduces fear, allowing more natural movement patterns. Strong joints come from exposure, adaptation, and intelligent progression. Joint strength is not built in comfort, but in controlled challenge. Avoiding stress removes the signal required for structural adaptation. But reckless loading exceeds tolerance and creates unnecessary setbacks. So the goal is precise stress, not maximum stress. Now, define what appropriate pain during training actually means. Mild discomfort during loading can be acceptable in many cases. Sharp or escalating pain signals excessive stress or poor control. Pain that lingers or worsens after training indicates overload. This distinction helps guide safe and effective progression decisions. Now examine how joint position influences load distribution. Different angles shift stress across various joint structures. Training across ranges builds more complete joint resilience. Avoiding deep ranges often creates weakness in those positions. Then those positions become injury risks during real movement. So gradually expose joints to deeper and varied ranges. Control should always expand before load increases significantly. Now consider speed as a variable in joint training. Slow training builds control and tissue tolerance under tension. Faster movements introduce reactive and dynamic joint stability demands. Both are necessary, but must be introduced progressively. Skipping progression often leads to instability under real conditions. Now examine external support like braces and straps. They can reduce load temporarily, but should not replace training. Long-term alliance may reduce internal stability development. Use them strategically, not as permanent solutions. Now, consider variability in training instead of rigid repetition. Repeating identical patterns limits adaptability of joint structures. Small variations distribute stress and improve resilience. This includes grip changes, stance adjustments, and movement angles. Variability trains joints to handle unpredictable conditions safely. Now, integrate strength with mobility rather than separating them. Mobility without strength lacks control at end ranges. Strength without mobility limits usable movement capacity. Joint health requires strength expressed through full available range. This is where controlled deep movements become valuable tools. Now, address long-term perspective in joint development. Joint tissues adapt slower than muscles, but retain improvements longer. This means patience produces more durable structural resilience. Short-term progress chasing often sacrifices long-term joint health. So progress should be measured in months, not sessions. Now combine all elements into a simple, practical framework. Load joints regularly with controlled, tolerable stress levels. Progress gradually in range, load, and movement complexity. Monitor response and adjust based on delayed feedback signals. Support adaptation with sleep, nutrition, and recovery habits. Include variability and multi-directional movement in training. Train both strength and control across full joint ranges. Reduce reliance on passive support over time. Stay consistent rather than chasing aggressive short-term gains. Strong joints are built through intelligent exposure, not protection. Many people think joints are fragile, but they are adaptable tissues. Adaptability depends on exposure to appropriate and repeated mechanical stress. Without exposure, tissues lose tolerance and coordination deteriorates progressively. This is why long rest often increases sensitivity instead of reducing it. Now examine stiffness, which many confuse with stability and strength. Stiffness limits motion, but does not guarantee controlled load distribution. True stability requires strength applied through coordinated muscular timing. This coordination protects joints during dynamic and unpredictable movement conditions. So passive tightness is not a reliable substitute for active control. Next, consider how fatigue influences joint loading and movement mechanics. Fatigue reduces motor control and alters force distribution patterns. This increases stress on passive structures like ligaments and cartilage. So technique often breaks down before muscles fully fail. Training should account for fatigue, not ignore its mechanical consequences. Now examine load tolerance as a moving target, not fixed capacity. Sleep, stress, and prior sessions influence daily joint tolerance. So identical loads may feel different across different training days. Autoregulation helps match load to current physiological readiness. This reduces injury risk while maintaining progressive overload principles. Now consider connective tissue stiffness as both benefit and limitation. Higher stiffness improves force transfer, but reduces energy absorption capacity. Lower stiffness improves shock absorption, but reduces force efficiency. Balanced stiffness allows both performance and protection under varied demands. Training should therefore include both controlled and reactive loading patterns. Now address the misconception that pain-free equals fully prepared. Absence of pain does not guarantee adequate tissue capacity. Capacity must be built beyond daily demands to prevent future overload. This creates a buffer between training stress and injury threshold. That buffer is what defines resilient and durable joint systems. Now integrate joint training into overall program design. Compound movements already load joints through functional movement patterns. Accessory work can target weak links within the kinetic chain. Isometrics, slow eccentrics, and controlled ranges build foundational capacity. Dynamic work develops reactive stability and real-world movement tolerance. This layered approach creates comprehensive joint resilience over time. Now connect mindset to joint training outcomes and long-term progress. Fear avoidance reduces exposure and limits adaptation potential significantly. Confidence encourages gradual exposure and improves movement quality naturally. This psychological factor directly influences physical adaptation outcomes. So education reduces fear and enables better training decisions. Finally, redefine joint health as capacity, not absence of pain. Capacity means tolerance to load, speed, and movement variability. This is built through consistent, progressive, and intelligent exposure. Protection without progression leads to long-term fragility and limitation. Training builds resilience by expanding what joints can safely handle. This is the shift from avoidance to controlled adaptation, from fear to understanding, and from weakness to structural strength. Joints do not need protection from load, but preparation for it. That preparation is built through progressive and well-managed stress. Strong joints are earned through exposure, not preserved through avoidance.